Hello and welcome. This is part two of our tire information videos. If this is your first time here, then welcome. Check out my channel and watch part one when you get a chance. But let's get going here. Okay, continuing with what we started, let's go back to the tire placard. Good home base, I think. Last video we covered the tire size, also known as aspect ratio. And again, this tire placard should be located on all vehicles when you open your driver's side front door at the B pillar, the lower portion. Here's our load and speed rating as well as our recommended tire pressure. Let's start with the load and speed rating. It's actually our load index and speed rating. And here it is. If you watched last video, this should look familiar, but this time we're going to erase some different stuff. Last video we talked about the 245, the section width, 50, the aspect ratio, and the 17, the rim diameter. So we're going to erase those. And we're left with this PR98V. We're going to get rid of the P and the R for now. And we're talking about the 98 and the V. What are those things? The 98 stands for your load index, and the V stands for your speed rating. For all intents and purposes, the load index is your load rating. It's important to not mix these up. This is the most common problem here. When people see the 98, the number, they think that's representative of speed, and it's not. That's your load rating, and the letter is your speed rating. In order to find out what that load rating means, we have to look at a chart. It's called a load index because we have to cross-reference that number from the index value to a load value on a chart. It's not something we have to memorize. But here's what we do need to know. First of all, that there is a chart that exists for this. Next, the higher the load index value, the higher the load capacity of the tire is. This is how much weight the tire can safely hold up. And remember, we have 4 tires to account for the total vehicle weight. Finally, we must ensure that we're installing a new tire with a load rating that's the same or better than the manufacturer's specifications. For example, I would only install a tire with a load rating of 98 or higher for this vehicle. Looking at this chart, these are only 3 values that I just happened to randomly select. The chart I referenced when making this PowerPoint, there were 19 different values, 80 to 99. But as the number increases on the load index, the load capacity also increases. Now, your speed rating is a letter versus a load rating number value. And again, we got to have a chart to reference the speed rating value to find out what that letter means. And most of the time, as the speed symbol descends the alphabet, the tire's maximum speed rating increases. But that is not always true here. Check out the H. It's out of place. It's the only one out of place, but it expresses the importance of cross-referencing the symbol with the actual value in order to make sure we're installing the proper tire. Once we get past the letter V, we're dealing with Z-rated tires. But at the end of the day, we just need to make sure we're installing a tire on a vehicle that's the same or better than what the placard instructs. Make sense? Okay, back to the placard. Let's talk about tire pressure. Real quick, guys. Check out how we have the same size tire front and rear, but different tire pressures front and rear. This is very important. It is a common mistake to try and figure out tire pressure by looking at sidewall data located on the tire itself. The tire manufacturer does not determine recommended tire pressure. That's the job for the vehicle manufacturer. The tire company does not know what vehicle the tire will be installed on when they make the tire. Ignore any data on the tire when setting tire pressure. If the values are the same, it is 100% coincidence. No ifs, ands, or buts about it. You get your information off the tire placard, and here's why. These values come from temperature. We only have a small section of tire actually making contact with the road surface. That's prime real estate. And we want minimal tire wear, right? Of course we do. A tire that's over or underinflated will reduce our contact pattern and prematurely and unevenly wear out our tires. If you think about it, if you have a big, beefy truck, I don't care how big those tires are, if you take one tire and you actually look at what's touching the ground, it's probably about the size of my hand. We don't want it to be half the size of my hand. Here's an example of where we want to be. When the tires are warmed up, the tread temperatures are even. The vehicle manufacturer, not the tire manufacturer, selects a tire, then tests it by inflating it. Then they drive a car, finally measure temp. If the temp's not even, the tires are not inflated properly. Think of it like they just pick a number. I don't know, 30. Let's see what it does. 30 psi all around. They hit the road. Once those tires are warmed up, if the tread from the center and the edges are even, we're good to go. If they're not, we got work to do. Here's an example of an overinflated tire. Think of a tire like a balloon. If it's overinflated, it'll balloon out, and the center is going to heat up faster than the edges, so it's going to be hotter. It's making more contact with the road surface than the edges are. If you look to the left, we're starting to wear out that center tread. This leads to premature center tread wear, increasing stopping distance, decreased acceleration performance, as well as less responsive steering. Remember, the vehicle is only moving, steering, and stopping properly if the tires let it, and only to the extent that they do. Tires are the only part of the car touching the ground. So we want to make sure we have a great contact patch on there. If we see this wear, it is not an alignment problem. A customer might think, hey, my tires are wearing unevenly. I need an alignment. Not if they're worn out like this. There's no wrench you can grab on an alignment rack, and there's no nut you can turn to change this. That is an overinflated tire. You need to replace the tire, and you need to have a conversation with the customer about tire pressure. Okay, on the flip side, underinflation will wear the tires exactly the opposite way. The sidewalls will be overflexed, causing the edges to make more contact with the road surface than the center tread. When we see premature inner and outer tread wear, it's safe to assume the cause being underinflation. Make sense? It's exactly the opposite. Now, underinflated tires are actually the leading cause of tire failure, aka blowouts. And the last time I checked, blowouts cause the most car accidents. Here's why low is worse than high. They're both bad, but when the sidewalls flex when you're low, they pack in a ton of heat and they take the tire out and they blow the tire out. That's why low tire pressure monitoring systems are government mandated, just like seatbelts, backup cameras, and airbags. As of 2008, every single car that was built from that point forward by law had to have a low tire pressure monitoring system. It's not a nice option that you pay extra money for. It has to be there, otherwise they're not allowed to sell that vehicle as of 2008, just like seatbelts. Okay, review time. Let's go. Technician A says a vehicle is equipped with a P26560R16 89V tire. Technician A says the 89 represents the tire's load rating. Technician B says the tire's maximum speed rating is 89 miles per hour. Who is right? Again, we are here to find the wrong answers, not the right answers. And we are here to separate Tech A and Tech B. We're answering two true or false questions at the same time, but we don't have to do them at the same time. So let's talk about A, and we don't care about B yet. Even if B says something that's unrelated, if it's true or false, it's yes or no. If B says the sky is blue, B is right, even if it has nothing to do with tires. Anyway, Tech A says the 89 represents the tire's load rating. Well, we see the 89, and 89 is the load rating. So before we read B, we know A is right. So we get to cross 2 off. If A is right, what do you think we can cross off? I'll give you a second. It's not neither. It can't be neither. There's another one we get to cross off, and we haven't even read B yet. It's not B. B could be right, but B is not right by himself. So now we're left with two answers, and we haven't even read B yet. So B says the tire's maximum speed rating is 89 miles an hour. Well, our speed rating is the V, not the 89. And 89 has nothing to do with the load rating or speed rating directly. Those are index values for us to plug into a chart. So B is for sure wrong. And if B is wrong, we get to cross off C. The answer is A. All right, question 2. Let's say on this one, we read Tech A and don't know the answer. I want to show you how to chip away at it this way. During inspection, a tire has excessive center tread wear. Tech A says the wear was caused from underinflated tires. Tech B says a vehicle out of alignment can cause this type of tire wear. Who's right? Let's say we read A, the answer is either yes, no, or I don't know. We choose I don't know. I don't know if A is right or wrong. So we ignore A. We go to B. Technician B says a vehicle out of alignment can cause this type of wear. They said excessive center tread wear. No way. B's wrong. And if B's wrong, we cross off B. And then we also get to cross off one more. I'll give you a second to think about it. If you pick C, you're right. If B's wrong, it can't be both are right. So we get to get rid of two of them. Now we're left with A and D. Okay, let's go back to A. We didn't know A, but at least now we have a 50-50. Like A says the wear was caused from underinflation. Then we think a little harder about it and we go, no, it would be the opposite of that. If it were underinflated, the edges would be worn, the center would not be worn. So A is wrong as well. The answer is D. All right, extra credit. What sensors are used to determine vehicle speed? We haven't talked about any of this, but I want to see what you guys say. Put it down in the comments. Number 2, going back to the question earlier, what's the tire diameter from this video's first review question? If you don't know how to do the math, watch video 1. And finally, thank you guys. Like, comment, subscribe, and see you next time.